Okay, welcome back to the next session in Module 4. In Module 4, you people have come across pneumatic control system. In pneumatic control system, especially when it's come to the pressure control valves. In the last class, you people have studied about different kinds of pressure control valves, their direct method of controlling the valve and indirect method of controlling the valve. When it's come to the direct method of controlling the valve, there is no controlling action will be performed on any type of the actuation system. Means whatever the fluid get entered in the valve, that will going to operate the actuation system or the cylinder by extension and retraction of the piston. Means in direct way they are controlling the amount of fluid flow by fixing the needle or by rotating the screw with the help of the needle, which is not transferring the flow of fluid, and with the help of ball type of devices or the puppet valves, etc. When it's come to the indirect type of controlling the valves, in indirect way, there the main valve will be there. With the help of the pilot valve, they are controlling the main valve. In many of the applications, so some restriction forces will going to oppose the flow of fluid once the piston is get extended to do any of the operation. During that time, the amount of force applying on the valves will be more. To overcome this issue, they are using the pilot valve. Means here indirectly they are controlling the main valve by supplying minimum amount of flow rate of fluid inside the main valve. By controlling it, the actuation speed of the cylinder is also get control. In similar fashion, when it's come to the flow control valve, in today's session, I am going to complete these flow control valves. The first topic is about the flow control valve and its type. Next, we will move on to the shuttle valve, and the next one is about quick exhaust valve and twin pressure valve, and the last one is time delay valve. Now the first thing is about the flow control valve. Even in our hydraulic systems, in the second module, you people have come across flow control valve. The flow control valve is used to control the rate of flow of fluid inside any of the system, whether it is an hydraulic system or it is a pneumatic system. Means we are controlling the rate of fluid flow. Why we are controlling the rate of fluid flow? Because in many of the operations, smooth running of the piston movement is necessarily required for us. Means some of the times there will be jerk while moving the piston from the retraction to the extension or extension to the retraction. Means the speed of this piston is maximum. To overcome that issues, we are using this flow control valve. When it's come to flow control valve, there are different kinds of valves are there. Check valve will comes to the picture, shuttle valve will be there, quick exhaust valve will be there, metering in valve type of valves will be there, fixed flow control valve will be there, variable flow control valve will be there. In variable flow control valve, one more type is there, that is nothing but reverse free flow type of valve. Means we are controlling the rate of fluid flow with the help of the valve, due to which the speed of actuation of the piston inside the cylinder is get minimized. Means for smooth running operation of the piston, we are controlling the flow of fluid which is get entered into the any of the system, whether it is hydraulic system or pneumatic system. For that purpose, we are using flow control valve. And also one more term they will going to call it, is used for monitoring the amount of flow of fluid that is getting involved in any type of the application or any type of the operation. This is about the some of the introduction regarding about the flow control valve. When it's come to the fixed type of flow control valve, we are using this symbol. Means here there is orifice diameter is fixed, and they are not going to vary the flow of fluid with the help of any other external devices like needle or ball type or puppet type of valves. Means here the orifice diameter is fixed. With that fixed diameter, the amount of fluid flow coming out of the diameter will be controlled, because here the variations will be there based on the requirement of the orifice, based on the requirements of the applications, by varying the diameter of the orifice that is used in that fixed type of flow control valve. And the second one is about the variable flow control valve. This is symbol for variable flow control valve. Here with the help of the needle or with the help of the puppet or with the help of the ball, devices, we will going to control the flow rate by varying the required amount or by turning it the needle or the screw present over to control the flow from inlet to the outlet. That is about the variable flow control valve. Next, when it's come to the types of flow control valve, here we have two types of flow control types when it's come to the flow control. One is we are controlling the flow rate at the inlet. If you are controlling the flow rate or metering the flow rate at the inlet, that is the first one, and the second one is controlling the flow rate at the outlet, or it is also called as metering outlet. Means here we are controlling the amount of liquid flow that is get into the cylinder by at the inlet or at the outlet, and also both the cases are also possible by using the reverse free flow type of variable control type of valve. But in your syllabus we have only two types, that is metering inlet and metering outlet type of flow control valve. When it's come to the metering inlet type of flow control valve, you can observe the diagram present over here. Here this is the inlet port, I am going to call it as A, this is the outlet port, I am going to call it as B. Means this is double acting cylinder. Why it is double acting cylinder? By looking at the ports present over here, you can clearly understood this is double acting cylinder. You can observe here, this is port A, this is port B. If I rub this one of the port or if I remove this, it is single acting cylinder. Means extension and retraction of the cylinder is possible only through with the help of only one port. Now here we have two ports for the extension and for the retraction. Means here it is metering inlet type of flow control valve. I am attaching this variable flow control valve at the inlet. Means we are controlling the inlet flow of the fluid that is getting into the cylinder. Means here once if I allow the flow of fluid from the pump to the valve, once after it is get allowed, the variable flow control valve will get adjusted to the required amount of flow that should get for any of the application. Now here I am adjusted the knob or the screw for the inlet and outlet of the valve. Once the flow is get adjusted, the required amount of flow is get to the cylinder. After get into the cylinder, now it is at the retract position, the cylinder moves from retraction to the extension. Means it is getting moved. Means we are controlling only the smooth actioning of the cylinder for extension purpose only for extending the cylinder. For that purpose we are metering the inlet port. We are metering at the inlet port. Means the smooth extension of the cylinder to the tail end. There you can observe the resisting force will be there to which is get connected to this piston. Means it is doing some other operation or it is going to lifting the load. Means some force will be there, but we doesn't require the fast movement of the piston or fast lifting of the load or fast movement of any of the operation. We require only the smooth movement of the operation. For this, very good example is in the buses, you can observe the door opening and closing application you people have seen there. There, once the door is getting closed, it is the cylinder is exactly at the extension position. It is exactly at the extension point, but while moving back, it will come back to the retraction position. There, the metering is possible while retracting the cylinder. Means while retracting it, the variable flow is get adjusted there. Means whatever the liquid present inside that cylinder is should be minimized. Means we need to control it. Means with the help of variable flow control valve, we can't control the amount of fluid flow from pump to the actuation system, and also we can control it from the cylinder. Means whatever the oil present inside the cylinder, again it is coming back to the tank or to the reservoir, we can also control that also. Means in that application you clearly observe, once this door is get closed, the cylinder is in extension position. Means the amount of fluid is already extended the cylinder. Now the door is closed. Now I want to retract it back to its original position. Means I need to open the door. During the time you people have observed it, the door opening is possible only by smooth movement of the piston inside that cylinder. Means for that smooth movement, whatever the oil present here, means whatever the oil present here, that should be variably controlled with the help of variable flow control device. And some of the times they will go for using the shuttle valves or some other different kinds of valves for controlling it. That is about the metering inlet. Next, when it's come to the metering outlet, here the variable flow control valve is fixed to the outlet of the cylinder port. Means this I am going to call it as A, this I am going to call it as B. I have connected the variable flow to the B port. Here the application remains same, means for closing we required smooth operation, but for opening we required fast operation. And also these kinds of metering inlet and metering outlet application can also be applied to shaper machine. In shaper machine it is quick return motion type of machine. There when it's come to the for the extension we can give the material removal process. For retraction we can go for the fast movement of the shaper, because you can observe it while cutting the material, it is moving at the required amount of speed, but while going back it will move at the faster rate. For that application also this metering in and metering out type of valves can be used. This is regarding about the types of flow control valve. Next is about the shuttle valve. Shuttle valve is one type of valve in the flow control valve which is automatically operated valve. Means it doesn't require any of the actuation system, whether it is a push button type or any of the type. It only requires the 3 ports and 2 positions are necessarily required to operate these kinds of valves. Means you can observe the 3 ports present over here. One is for the A port and the C port and the B port. Means 3 ports are necessarily required to operate these kinds of valves. And also this shuttle valve is used to operate only single acting cylinder. To operate double acting cylinder they will go for some other kinds of valve. Only for the single acting cylinders, to operate single acting cylinder they will go for the shuttle valve, because you can observe in the A port if the amount of fluid enters here, this is called as the poppet will move to the B port. Means I am allowing the fluid only to the A port. Now the poppet will move in this direction. During that time the flow will going to happen from A to C. And again if I close this, if I come to the B port, I will stop supplying the fluid to the A port. When it's come to the B port, if I supply fluid to the B port, the poppet will get close to the A port. Means the fluid enters only from B to C. It's clear. Means here the inlet of the poppet is located at the 2 opposite directions, one at the A port and another at the B port, and the outlet is get connected to the C port. This is get connected to the cylinder edge. Okay. For shuttle valve it requires 3 ports, 2 inlets and 1 outlet. When it's come to the symbolic representation, this is the symbol what we will going to use for the shuttle valve. This is the check valve, means it is allowing the flow over here, and again one more direction from this side, again this is get connected to the cylinder port, any of the port, whether it is A port or B port, but with the help of shuttle valve we will going to operate only the single acting cylinder. Now I will be explaining this application. You can observe here, this is single acting cylinder with spring return. You can observe the springs present over at spring return in the rod end. And this single acting cylinder is get connected to the shuttle valve, and here we are using 3/2 directional control valve. Why it is 3/2? 3 stands for 3 ports, one is from the pump to the port A, another is to the reservoir or tank. You can observe here P, A, R are the 3 ports present over here. Means it is 3/2 direction control valve with push button type of operated. Again here also it will be the same, it is also 3/2 flow control valve, 3/2 flow control valve with the directions of P and the port A and the reservoir. Okay, now you can observe here in this application, once the fluid enters from with help of this operating this push button, means if I press this push button, the pump is present here, it will be in the first position, the fluid enters the A port, through this check valve. Means check valve will be one direction flow valve. Here the flow enters, means the retraction of the cylinder, extension of the cylinder is possible. Cylinder will get extended. But while returning back, the fluid present over here will going to retract back to its original position by the spring compression. Means the already amount of force is get applied on the spring. Once after the operation is get finished, the spring will going to push back the cylinder to its original position. During the time, the flow will not be possible in this direction through the A port. It will come in this direction. There, the position of the push button will get changed, valve will get changed. Means first it is in the first position, next will be in the second position. Means amount of fluid coming out of the A port to the reservoir. You can clearly observe the arrow written over here. And also this shuttle valve purely works on OR gate. Means you can observe here, if I supply the air at the inlet port, puppet will move to the B port, and from A to C will be the outlet. The flow will be possible from A to C. Next, I will stop supplying the A to the inlet port, and next I will move to the B port. If I supply the pressure compressed air at the B port, the puppet will get moved from here to here, and the A port will get closed, and the flow is possible only in B to C. It's clear. And also in the next case, you can observe, if I apply the compressed air both at the inlet port and A port and also at the B port, during that time the compressed air pressure will get fixed in both the inlet and both the inlets. During that time, the puppet stands exactly at the center. In this condition, the flow is possible both from A and also from B. For that, if I write the OR gate, this is the inlet port, this is the outlet port. These two are the inlet ports, A and B, this is the outlet port. If I supply the A at the inlet port, I am going to call it as 1, B will be stopped, the flow is possible. If I supply the air at the B port, then the flow is possible. It's clear. If I supply at both the ports, it is also possible, because it will stand, the puppet will stand exactly at the center. If there is no supply, there is no movement of the spool. It's clear. Means shuttle valve purely works on OR gate. That is about the application. Here also the same thing. When it's come to the here, when you operate the push button, the flow is possible at the first position from P to A. Next, the flow will going to allow to the check valve, means extension of the cylinder will going to happen. And while retracting back, you can clearly observe this flow will get retracted. This flow will be returned to the reservoir with the help of the port A itself, because of the compression force that is already present in the piston, rod and side. And also one more thing, some of them will get confused. Once while extension of the cylinder, some amount of fluid will get stored here. What about that fluid? Means while retraction back, this amount of fluid enters back to the reservoir. Once after this is get entered, this retraction is possible in any of the application. Before the entering of this amount of fluid already entered, it is not possible to get retract back to its original position. Means whatever the fluid already entered, it will get blocked in this check valve position. Again, it will be coming back to the reservoir. Once after coming is over, next whatever the amount of fluid present here, that will be back to the reservoir at the second position. It's clear. That is about the working of shuttle valve. Next is about quick exhaust valve. Here you can observe the quick exhaust valve. The quick exhaust valve and the shuttle valve works on the same principle. You can clearly observe it also have three ports, port A, port P and port R. It's clear. Means here once if I allow the flow of fluid from the P end, the flow will going to compressed flow of air will going to push the puppet present here to the R end, and the flow will be transferred at the A end. Means here R is the outlet, A is also one of the inlet, P is also one of the inlet. And also if I allow the flow of fluid again while coming back from the port A, there the compressed air will going to push this pipette back to the inlet port P, it will get closed here, and the flow is possible again from inlet A to the outlet R. Means here quick exhaust valves are used for fast exhausting in any of the applications. Why these kinds of valves are used? In some of the applications, while doing the cycle, whether extension or retraction of the cylinder, if power cutoffs or any damages happens in the system, automatically the flow will get stopped. During that time, the amount of fluid in any type of double acting cylinder is get stored in the cylinder itself, or the amount of air that can entered into the pneumatic system or the cylinder head, there it will get trapped over there. To release that trapped amount of air that present in that cylinder, we are using quick exhaust type of valve. Means there quick exhaust will be there with these kinds of valves. Now when it's come to the application, it also purely works on the type of OR gate type of logic. Again here you can observe the diagram over here. This is also 3 by 2, means 3 ports are there, that is P, A and R, 3 by 2, 2 positions, 1 and 2 positions for the push button type of direction control valve. Once if I allow the compressed air from the compressor to the quick exhaust valve, it will go to the retraction end of the cylinder. Now the cylinder will get extended back. Again while coming back here, there is no the required amount of fluid again will not come back to this valve itself, to the reservoir. There one more direction we have provided here, that is nothing but the reservoir symbol is provided, that will going to send the fluid to the vent or to the atmosphere directly. In this case we are using 2 valves here. You can clearly observe, once after the compressed amount of air enters, that is also released, and also while retracting back, whatever the amount of fluid present inside the cylinder, that is also released. But here with the help of one kind of valve, quick return is possible. Quick return means the amount of air that is supplied inside the cylinder, that should be released with the help of the quick return type of valves by allowing that air to the atmosphere. Means quick return, we are releasing to the atmosphere directly. Because when it's come to the hydraulic, we are returning to the reservoir. When it's come to the pneumatic, we directly releasing that air to the compressed air directly to the atmosphere in a smooth manner. You can clearly observe here. Means here from pump to the port A, we are supplying the fluid. There the extension is happening. Again while retracting back, whatever the air get trapped here, that is released with the help of the valve. But while retracting back, whatever the present of air present over here, that will be supplied to the atmosphere itself. This is about the quick exhaust valve. The main function of quick exhaust valve is nothing but whenever the air get trapped in any of the cylinder during the flow fluctuations or any damages going to happen, during that time quick release of the air that is present inside the cylinder to the exhaust or to the atmosphere is possible with the help of these kinds of quick exhaust valve. Next is about twin pressure valve. In twin pressure valve, the twin they are saying that is nothing but the operation is possible by supplying the air at the 2 inputs, by supplying the air at the 2 inlets. You can clearly observe the 3 diagrams I have written over here. This is the graphical symbol of this twin pressure valve. In twin pressure valve, the air supply will going to happen from the input A. Means I am not supplying the air from the port B, I am supplying the air from the port A. If I supply the air from the port A, this spool will get moved to the port B, means this spool will going to close this port B. And here the supplied air will not going to pass to the C outlet, means it is get trapped here itself. It is not possible. Again I will come to the second case. You can observe here, if supply the amount of fluid flow from the port B, here the air will going to move the spool, but again it will get restricted at this end. Means there is no movement of flow of fluid from B port to the C outlet. And in the last case, you can clearly observe here, I am supplying the flow of air from both the ports, A port and the B port. You can clearly observe here, from both the ports I am supplying the air. While supplying the air from both the ports, this spool will going to stand exactly at the middle of the valve, due to which the flow is possible both from A direction and also from the B direction to the C outlet. These kinds of twin pressure valve is purely works on AND gate logic. If I write the AND gate logic, it purely works on AND gate. If I give power supply to A, power supply not to the B, again there is no power supply to the outlet. Again, if I stop giving power supply to the A port, if I supply power to the B port, again it is not possible. If I give power supply for both the condition, then it is possible, means the flow of fluid is possible. If I am not supplying the flow of fluid for A and B inlet, it is also not possible. Means with the help of these kinds of twin pressure valve, here we are supplying the amount of compressed air for both the ports, A port and the B port. And these kinds of valves are used in punching and dyeing machines. There the operator will going to operate two push buttons at a time itself. Means he is operating two push buttons at a time. One is for punching, another is for keeping the punching material exactly on the top of the die. In that application, if the semi-automated machines are used, only punching is possible with the help of one kind of valve. Means if I press the push button, only punching is happening over there, due to which the operator will going to keep the material exactly at the top of the die. The material is getting pressed. But by using these kinds of valves, at a time two kinds of operation is possible. Means punching is also possible. The operator and will not going to move the material. We are removing that operator hands by automating it by using twin pressure valves. If at a time I will going to press the push button, both the operations is possible at one cycle itself. That is why we are using twin pressure valve. And the last one is time delay valve. This is the diagram of time delay valve. You can clearly observe this is the needle of is nothing but the flow control valve. This is the check valve, and this is the pilot valve, and this is the chamber. Means for time delay valve we require flow control valve, check valve, chamber, and the pilot control valve. When it's come to this time delay valve, the time delay valve is used for the operations. Means if the sequence of operations are there should be gap between one operation to the next operation. Means we need to maintain the delay time for one operation to the another operation. During that time they will go for using this time delay valve. In these kinds of operation, once from the inlet port, if I supply the amount of fluid here, the required amount of fluid flows through the check valve. This check valve is one directional flow valve. That amount of fluid will get stored in the chamber. It will get stored in the chamber. Once after the chamber is get filled, it will go into create the pressure automatically, due to which the pilot will get moved from initial position to the extension position. Means the pilot movement will be there, or the spool movement will be there, due to which the one more compressed air is already get connected to this port, which will going to allow the flow of fluid in this port A. Means with help of inlet port I am supplying the compressed air. The check valve will going to allow the amount of fluid to it. It will going to get stored here. With the help of that, again the spool will get moved and the spring will get compressed. Again the one more port is provided over here that contains the compressed air. That compressed air enters here. Again it will go back to the port A, that will going to extend the cylinder. It's clear. But once the amount of fluid get filled over here till here, means extension is already over of the spool. Again when we need to come back to the retraction position. During that time whatever the amount of flow of air present inside the cylinder should come back to the tank or to the reservoir or to the atmosphere. During that time, the compressed force of the cylinder will going to release it, and it is one direction flow check valve. It will not allow the amount of fluid enters here, but it is allowing only in this direction. During that time, here the flow control valve is present here. This is needle type of flow control valve. We can also use ball type or puppet type of flow control valve. It will going to allow the required amount of flow over here. It will come back, means whatever the compressed air that was coming from the inlet port, it get fixed, that is coming out here. But the port A will going to allow the fluid, that fluid enters to the atmosphere through this tank. Means again the spool movement is happening with the help of the spring. This is regarding about the time delay valve. Means here delay time is happening by introducing the chamber over here. Means we are sending two compressed airs, one at the inlet port, one at the pilot operated valve, that is get fixed. Means they have combined all three different valves: flow control valve, check valve and the pilot operated valve. Here once the compressed air fills the chamber, it will going to push this spool. During that time, P end the compressed air will going to pass to the port A. Again while coming back, this air should be drawn. To draw that kind of air get fixed here or get filled here will be possible with the help of this needle. Their minimum amount of fluid is coming out of it, whatever get filled over here, and from the port A again the air should get back to the vent or to the atmosphere. That will be possible, and also it will come out with the help of this port, that is nothing but the T port to the atmosphere. This is regarding about the time delay. Here delay is happening with the help of the chamber present over here. This is regarding about different kinds of flow control valves and their applications and their types and their construction. Thank you.